Hi. So yeah, another talk about embeddings. We won't try to stabilize them. We'll try to actually reconstruct them, because this is a work, as mentioned, rethinking the privacy of the text embeddings. And this is a reproducibility study that me and my peers from the University of Amsterdam did this year. And yeah, so when kind of thinking of the text embeddings, or like embeddings in general, for us, they are just like sequence of numbers. They do not like really mean much. And we don't really think of them as like some kind of like really sensitive human understandable information. But as it turns out, you can actually apply pretty trivial methods to reconstruct the embeddings. So they are not as private as you can think of. For example, a method called vexitext is an actual like embedding immersion method that can reconstruct the original text, including whatever, names, addresses, and other privacy sensitive information. And all it needs is just like an access to some black box model, something that you can actually query and get these embeddings. How it works? Well, basically you need a model. You pass some kind of like a sequence to it and get the original embeddings, which we call target. What we do, then we kind of smash them together. So we take the original text embeddings, generated initial embeddings, our like initial guess. Then we use additional word tokens, and importantly, difference between the guess and original embeddings, so we can actually know how far or how close we actually are. Then what do? We kind of train the inversion model, which is a sequence model to acquire the next text sequence. And we kind of have like a correction, like our guess, what the initial embeddings can actually like represent. Then what we get multiple new guesses using the beam search, using the initial frozen text encoder to get multiple new candidates. And then based on their closeness to original target ones, we pick the top ones to follow up in the further iterations, because we do this step multiple times. The longer, probably the better. We'll see. So the research focus of this paper was actually, first of all, to check if the initial statements are correct or not. And what we also did, we did an extensive parameter sensitivity analysis. We tried to reconstruct even more sensitive inputs than like addresses or names, in this case, passwords. And what we did, we actually inspected additional different methods on how to defend against methods like these using embedding quantization. So first of all, when reproducing, we kind of dealt with two different pre-trained models that were given by the authors. They were based on the GTR and OpenAI sequence models. They did in-domain and out-of-domain settings on the 19 different datasets from the BEIR benchmark and SMART dataset. So while reconstructing, we kind of, saw that authors did a pretty good job. They didn't lie with their numbers. We kind of got everything as they did, except for a couple of cases. So there were like some number differences that we kind of try to attribute towards like low sample sizes and unclear data splits. So something that was not that well defined within the paper. There was maybe possible usage of different models that authors did not provide. But most importantly, what we kind of saw that, well, everything worked fine, but except on this like particular case when we take ADMS 128 model and we try to reproduce results on having the 32 tokens as a max, basically just concatenating the text. And we saw that our results differ by a mile. So inspecting it, we kind of find that this model, while is able to kind of reconstruct the text, actually is overfitting on the sequence text on the sequence length that you're giving to it. So as you can see here, for two different models trained on the different sequence lengths, as you start shifting from the initial training sequence size, the model performance tends to differ. So this is what we find out. What we additionally looked into is the relationship between these two really important hyperparameters for this method. So number of the steps that you kind of iterate and try to reconstruct the text, and the beam width size. And so as you can see, the more the better. But then the question is, how much more is too more? So as we found out, authors select the initial hyperparameters for their particular values, 50 steps of iteration as a max and a beam width of 8, because probably day, as well as we saw that the results actually plateau after the 50 steps. And what we see here is that beam width is more crucial than the number of iterations, but it kind of is more memory hungry. And of course, it kind of depends on your hardware, but having larger beam widths requires substantially more runtime to perform this operation. Well done. Additional extension. So we saw that these methods can reconstruct out of domain text, but how out of domain the text can actually be? So we went from the addresses and the names to like passwords. Well, passwords can actually be like whatever. So what we did, we reconstructed a new data set based on 3 difficulty levels of the passwords. First of all, being easy, like mostly words and some numbers, something that maybe your parents has as a password. Then we had a medium and a hard passwords, which should be actually pretty hard to reconstruct. And what we saw that one of the models, particularly ADAMS 128, was actually able to reconstruct 4% of the hard passwords, which is pretty insane, and 30% of the easy ones. So I guess we either have to have really hard passwords or like worse reconstruction methods than these ones, so they wouldn't leak. Additional extension, as mentioned, what we did, well, we kind of were thinking of different methods to defend against this vector text, or like similar methods that try to reconstruct the text given the embeddings. So what we did, we applied absolute maximum quantization and 0-point quantization methods on top of the embeddings. And we find out that actually for the retrieval setting, as these results here are presented based on the retrieval benchmark, the results did not change that much. But for the reconstruction, for the BLEU score, we can actually see that the drop in the performance is pretty significant. So we can see that quantization, well, is kind of a good method to defend against vector text. But one question that is still yet to be answered, so what happens if we actually retrain vector text on quantized embeddings? Well, yeah, so this is area for the future research. So for the discussions and conclusions, so yeah, first of all, we can confirm that authors did a pretty good job. They proposed a method that can reconstruct both in-domain and out-of-domain text with relatively good accuracy. And what's even more interesting, that we can actually reconstruct not like intent or like parts of the sequence, but we can reconstruct the exact sequence. So like names, addresses, and passwords are not safe in this case. We additionally confirmed that, well, model performance is tied to the training sequence length, so it kind of works the best if you match the max sequence length to the length of the training set. There's also a trade-off between the beam size and the number of iterations to consider when optimizing efficiency and recovery accuracy. Well, methods also generalize well both to out-of-domain reconstruction and in-domain reconstruction, as mentioned, even the cases for the passwords. And the proposed defense mechanism using the width quantization is actually pretty well working, but there's also additional there's also area for additional methods to try out here. Yeah, here you can find a link to our GitHub repository. There's a QR code to LinkedIn page of mine. Yeah, thank you.
What are the industry use cases of vector text?
Sorry?
Industry use cases.
Well, first of all, if you are considering starting your embeddings in some like GCS bucket or Amazon storage, well, try to make sure that those are not accessible to other like actors outside of your company, because even if these are like numbers, well, for us they do not mean much, but you can actually like to recover any like sensitive information that the users that we encode information that users let us to encode to. So it's kind of like a security question that they have to consider.